So, many multi-factor models have been introduced. The one thing to note about multi-factor models is that they are all extensions of the CAPM. For the most part, they use the the beta and the excess return on the market plus additional factors. So these the idea of multi-factor models is that the CAPM does not explain everything. So um, these models, the security returns um, are explained by many systematic factors. So we have uh, inflation, business cycle, the, the the direction of the market, and others as well. So political factors, so forth. So multi-factor models attempt to capture this. An example of a two-index portfolio here. So we have again, our capital R IT is excess return for security I and period T is equal to its alpha. In this case, we've got uh, a beta for security I in relation to the excess return on the market. So the beta for security I multiplied by the excess return on the market portfolio plus a T-bond, beta for security I in relation to treasury bond. So, and then the excess return of the treasury bond in relation so this would be the return expected return on the treasury bond minus the risk-free rate, and then again we have our residual or error term for that specific security during period I. So the idea here is this: we've introduced two explanatory factors. The first being related to the CAPM, and now we've added one that would hopefully explain the effective interest rates on the return for that security. So, two-factor security market line is simply the expected return for that security equal to the risk-free rate plus the beta for that security in relation to the market multiplied by the excess return on the market. So the expected return on the market minus the risk-free rate plus the beta in relation to treasury bonds multiplied by the excess return of treasury bonds. So the expected rate of return on treasury bonds minus the risk-free rate. That would give you a two-factor model. An example of a three-factor model is Fama-French three-factor model. Fama and French are two relatively famous finance professors who've done a considerable amount of research in this area. They have the three-factor model and five-factor model. They introduce these factors again in an effort to explain more than the capital asset pricing model does. So in this example of the famous French model, we're talking about Google again. So the return on Google minus the risk-free rate, or the risk premium associated with Google, is equal to the alpha for Google plus the beta of the market multiplied by the market risk premium. And then we add these two additional factors. The first is a beta high minus low. And high minus low relates to the theory that high book to market firms are undervalued and perform better than low book to market firms. So this is the first Fama French factor. So we multiply that by the return related to high minus low, and then the second factor is what's called small minus big. this relates to the fact that small firms tend to outperform larger firms. So the beta for small firms um, multiplied by that return, and then we have an error term as well. So the Fama-French three-factor model is very effective. It does explain more than the capital asset pricing model, and again is widely used. There are several successful investment firms that use the Fama-French model, or some variation of that model. Many people believe you have to add momentum to this model, which momentum would be the Carhart model. Basically, is the Fama-French three-factor model plus momentum. So, estimation results. So when we do this estimation, there are three aspects of a successful specification. Higher R squared. We're going to see that in a chart in the next slide. Lower residual standard deviation. So this lower residual standard deviation relates to the error term. So what it's saying is that we're doing a better job of predicting those returns. The smaller value of alpha. So there's less the lower residual standard deviation relates to per period. Smaller value of alpha relates to the firm's outperforming the market over time. So in Table 7.2, we have two regressions. We have our single factor model and three-factor model. This case, we're talking about Ford. We have our intercept, and then we have our excess return on the market. So and then in the brackets we have our T statistics. This tells us whether these numbers are statistically significant. And in order to be statistically significant, the T statistic needs to be somewhere in the neighborhood of 2, 1.95, 2, somewhere in that neighborhood. So we can see that in both cases, the excess return on the market is highly significant. However, with regard to Ford, our small minus big is definitely not significant, not anywhere close to 2. The high minus low, however, is getting close to being statistically significant, but it's not. R squared, so telling us how much these models explain, is slightly higher for a three-factor model. In some cases, it's with some securities is quite a bit higher. Residual standard deviation also goes down slightly, so we're not having, meaning our error terms are smaller.